In 72 AD, they faced a task that seemed impossible. A structure nearly as tall as a modern 15-story building, spanning an area larger than 4 football fields, all without a single steam engine, without cranes, without any of the machines we take for granted. No hydraulic lifts, no industrial pulleys, just human hands, basic tools, and an obsession with perfection that bordered on madness. The Roman Colosseum was not supposed to be possible, yet crews of thousands labored through scorching summers and freezing winters, moved more than 100 cubic meters of stone, and engineered a structure so sound that it still stands nearly 20 years later. How did they conquer a challenge that would test the limits of modern engineering? The answer begins not with genius, but with something far more dangerous: absolute control, relentless organization, and workers who understood that failure meant death. The Colosseum rose from the ruins of a despised emperor's palace, built on land seized from Rome's people. Emperor Vespasian made it a promise, a gift to the masses in the form of entertainment and pride. The site sprawled across the Campus Martius, a depression in the city's heart where Rome's elite had once indulged their darkest fantasies. Now it would become the greatest arena on earth. The dimensions alone defied belief. The outer wall stretched 188 meters around its perimeter, rising 48 meters high, with 4 stories of arches and columns that seemed to defy geometry itself. Inside, the amphitheater's arena measured 87 meters long and 55 meters wide, surrounded by tiers of seating that could hold nearly 50,000 spectators. To accomplish this without modern machinery meant rethinking everything about how stone moved, how structures rose, and how men could be organized to move mountains 1 block at a time. The stone began its journey in the quarries beyond Rome, where workers broke loose blocks of travertine using only wooden wedges and water. The Romans had discovered that water, when forced into cracks in stone, would freeze and expand, splitting the rock along natural lines. But this process was slow, demand requiring patience measured in weeks. Once extracted, each block weighed between 2 and 5 tons, too heavy for any wagon to carry through Rome's streets. The solution was the quarry itself, which became a massive workshop. Blocks were shaped and smoothed at their source, reducing waste and the burden of transport. Thousands of workers, many of them enslaved or conscripted, spent years in these pits, their hands bleeding, their backs bent under the relentless sun. The death toll in the quarries was as silent as it was staggering, recorded nowhere, acknowledged by no one, simply the cost of Rome's ambition. Delivering 100,000 cubic meters of travertine to the city required a supply chain that was as engineered as the building itself. Teams of oxen, sometimes more than 100 at a time, hauled sledges laden with stone blocks along specially constructed roads. The Via Sacra, Rome's sacred street, was reinforced with gravel and clay to bear the weight. Teamsters, organized in crews of 10 or more, maneuvered the sledges with leather harnesses and wooden rollers, each move calculated to minimize friction and damage. A single mistake, a block dropped or cracked in transit, meant weeks wasted and precious resources lost. The timing had to be perfect. Blocks arrived daily, in the exact sequence needed for assembly. A just-in-time delivery system that predated modern manufacturing by nearly 2 millennia. Foremen coordinated the flow, using nothing but hand signals, chalk marks on stone, and an almost supernatural understanding of logistics. If a shipment arrived out of order, there was nowhere in the city to store it. Work had to continue regardless, which meant crews sometimes dismantled partially finished sections to accommodate new arrivals. The real engineering challenge was not just moving stone, but lifting it. The Romans had no steam engines, no hydraulic systems, nothing but leverage, counterweight, and sweat. Enter the treadwheel, a machine as simple as it was ingenious. Picture a massive wooden wheel, sometimes 5 meters in diameter, with a rotating drum in the center. Workers stepped inside the wheel itself, walking in place as if climbing a never-ending staircase. Their weight turned the wheel, which wound rope around the drum, lifting loads with a mechanical advantage that could multiply human strength tenfold. A team of 4 or 5 men working in shifts could lift a 2-ton block of stone 15 meters into the air in less than 5 minutes. These machines were positioned all around the construction site, anchored to wooden scaffolding that itself required constant reinforcement as weights increased. The ropes, made from twisted plant fibers, wore out constantly and had to be replaced. Yet another logistical challenge managed by teams of ropers working full-time just to keep the machines functional. The wooden scaffolding that surrounded the Colosseum during construction was itself a marvel of engineering. It covered the entire perimeter and rose higher than the structure itself, creating a lattice so complex that modern archaeologists still debate exactly how it was designed. The main uprights, massive timber posts, sometimes a meter in diameter, were sunk deep into the ground and bound together with iron clamps and wooden joints. Cross-bracing created a framework that could absorb the constant stress of shifting loads. Workers clambered across these beams without harnesses or safety lines, balancing on wood worn smooth by thousands of feet. The scaffolding had to support not just the weight of workers, but also the treadwheels, the ropes, the blocks in transit, and the constant motion of thousands of men moving simultaneously. A single collapse would be catastrophic, killing dozens in seconds and halting work for weeks while the structure was rebuilt and inspected. Inspection itself was an art form. Master builders, men who had spent decades studying structure and stone, walked the scaffolding daily, checking for rot in the wood, corrosion in the iron, and sagging in the joints. They could spot failure before it happened, sometimes removing entire sections and reinforcing them while work continued elsewhere. The placement of stone required precision that seems almost impossible given the tools available. Once a block reached its position, held by workers balanced on scaffolding and ropes, it had to be lowered into place with absolute accuracy. Drift pins, tapered steel wedges, were hammered into grooves cut into the stone, forcing each new block into perfect alignment with those already in place. The gaps between blocks were often less than the width of a hair, a fit so tight that mortar could barely penetrate. Mortar itself, made from volcanic ash, lime, and water, was a Roman innovation that transformed construction. Unlike modern cement, this mixture grew harder over decades, its binding strength actually increasing with time. Mixing this mortar by hand, in vats sometimes large enough to hold a man, was back-breaking work. Laborers stirred constantly, making sure the texture remained uniform. Too dry, and it would not bind. Too wet, and it would flow away. The margin between disaster and perfection was measured in teaspoons of water. The 4 tiers of arches that made up the Colosseum's exterior represent some of the most sophisticated engineering of the ancient world. These were not simple stone archways, but load-bearing structures that distributed the weight of thousands of tons of masonry down to the foundation. The Romans understood, without benefit of calculus or modern physics, that the force in an arch was not vertical, but diagonal, that the tension traveled through stone in lines that could be predicted and managed. Each arch required a wooden framework, called a centering, built before the stone was placed, that held the arch in position until the mortar cured and the structure could support itself. Building these centerings, removing them, and then building the next set was a choreography that repeated hundreds of times over the course of the construction. Engineers calculated the timing down to the day. Too much time with a centering in place, and the wood rotted; too little, and the mortar was not yet strong enough. The margin for error was measured in hours. Behind every calculation, every measurement, every perfectly placed stone was a workforce of staggering proportions. At its peak, more than 10,000 workers swarmed the site daily. Enslaved people brought from conquered territories worked alongside free laborers and skilled craftsmen. The division of labor was ruthless and hierarchical. At the top, the master builders and architects made decisions. Below them, foremen organized the flow of materials and men. Below them, teams of specialists, stonecutters, masons, carpenters, riggers, and countless others. At the bottom, the generalists who carried, dragged, and hauled, their names never recorded, their labor measured only in the work they accomplished. The living conditions for these workers were abysmal. Housing was crowded and unsanitary. Food was basic and often scarce. Medical care did not exist. Injuries were common and often fatal. A worker who fell from scaffolding, who was crushed under a stone block, who became ill from infection, was simply replaced. The Roman state had an unlimited supply of disposable labor. The construction records, fragmentary as they are, suggest that the death toll reached into the thousands. Some estimates place it as high as 10% of the total workforce over the 8 years of construction. But the empire kept no official count. The workers died quietly, their deaths recorded only in family memories and gravestone epitaphs for those whose families could afford them. The engineering of the underground, the hypogeum beneath the arena floor, was, if anything, more sophisticated than the visible structure. Here, beneath where gladiators fought and crowds roared, lay a network of passages, rooms and mechanisms designed to move animals, stage props, and even entire fake landscape features up onto the arena floor. Trapdoors and elevators, operated by hand-cranked winches and counterweights, could raise a fully grown lion from the depths in seconds. The rooms beneath held cages for animals, storage for equipment, and quarters for the enslaved workers who spent their entire lives underground, never seeing sunlight. These mechanisms had to work flawlessly. A failure meant an animal loose in the crowd, or worse, a worker crushed in the machinery. The engineering accuracy required was staggering, with moving parts fitting together so precisely that the deviation from specification is often measured in millimeters. This was achieved through nothing but careful marking, hand tools, and the cumulative knowledge of craftsmen who had spent lifetimes perfecting their trade. The concrete that the Romans invented became the secret weapon of their construction. Unlike modern concrete, this mixture varied by region and application, but the basic formula involved volcanic ash, called pozzolana, lime, aggregate, and water. The beauty of this concrete was that it set underwater, allowing the Romans to build structures in flooded areas that modern engineers could not touch without pumps and dewatering. The Colosseum was built with a sophisticated drainage system that routed water to underground channels, yet the concrete would have held even if those channels failed. Testing this concrete was done empirically. Builders would create sample blocks, observe how they weathered, and adjust the recipe accordingly. Knowledge passed from master to apprentice in oral traditions that sometimes stretched back centuries. By 80 AD, nearly 8 years after Emperor Vespasian began the project, the Colosseum was ready for its inauguration. Emperor Titus, Vespasian's son, presided over a spectacle of unimaginable proportions. Thousands of animals were slaughtered. Elaborate wooden sets transformed the arena into mythological landscapes. The spectacle lasted 100 days, and when it ended, more than 100,000 people had witnessed Rome's greatest architectural triumph. They did not think about the thousands who died in the quarries or on the scaffold. They did not consider the enslaved workers crushed beneath falling stone, or the families torn apart to feed Rome's need for labor. They simply sat in their seats, marveled at the engineering, and understood that Rome's power had no limits. The Colosseum stood as proof that human determination, when properly organized and without mercy, could accomplish anything. Nearly 2,000 years later, the Colosseum still stands. Damaged by earthquakes and stripped of its outer stones by medieval builders seeking material for their own projects, yet fundamentally sound, modern engineers who study its proportions struggle to explain how it was built without computers, without hydraulic systems, without the thousands of conveniences that modern construction takes for granted. The answer is not genius, though genius was certainly involved. The answer is organization so complete that it bordered on totalitarianism, materials science developed through centuries of experimentation, and a labor system that valued human life so little that the cost was never calculated. As modern construction faces pressure to reduce waste and improve efficiency, the Colosseum reminds us that our ancestors achieved the impossible through nothing but will, knowledge, and at a cost we would find morally unacceptable today. The question is not how they built the Colosseum. The question is what we are willing to sacrifice in our pursuit of the next great monument, and what monuments will future generations judge us for having built.